Hello, today we're gonna talk about the sheafification of a presheaf. So what this does is that we take a presheaf and we wanna get a sheaf. So let's see how we define it. So now we'll give the construction. So we define the sheafification, which we denote like this: f sheafification of f by the following rule. So let's take, so if f is a presheaf on a topological space X and U is an open set of X, then we define the sheafification on the same topological space, and we take Sx in the product of the elements in U of the stalks, and we put some condition on these Sx, namely we want that for all X in U there exists the open neighborhood of X. So we have an open neighborhood, and we have an S-twiddle in f of v with S-twiddle y, so this is the germ of S-twiddle, is equal to Sy for all y in v. So this tells us that we can locally represent this by a section. So we have Sx, so we have Sx here, and then we have this neighborhood, and in this neighborhood we can locally represent it by S-twiddle, so with these germs of S-twiddle. And we need restriction maps. And what are the restriction maps? Well, that's easy. So for v subset u, so that's not the same v as here, we map just Sx for x and u to the same thing, just that we restrict to the elements in v. Okay, and now we call it sheafification, so it better be a sheaf. So that's what we're gonna prove now. The sheafification is a sheaf. So let's see the proof. So that it's a presheaf is quite easy to check. So you just have to check the restriction maps. That's not hard. So let's prove the sheaf conditions. So let's take an open cover of U by the UI, and let's check the first condition. So let's take elements S and T to be in the sheafification of U, where if we restrict to the UI, we get the same elements. Well, this just means that Sx is equal to Tx for all x in UI and for all I in I. And well, the UI cover U. S is just defined by some Sx. So this means that this holds for all x and u, and that just means that S is equal to T. So that wasn't hard. And for the second sheaf axiom, that's also not hard. So let's take elements Si, so which are some SIX for x in UI, which is in F, the sheafification of UI, where so if they should agree on intersections for all ij, and now we want to glue. So how do we glue them together? Well, that's not hard. So we define Sx to be Six if x is in UI. So let's check that this is well defined. Well, that's just because they agree on the intersection. So if x is in UI and in uj, then they agree. And we have this equality here, so this tells us that then Six is also equal to Sjx. Okay, and now that we've well defined Sx, we set S to be just this element, and then we get that S restricted to UI is equal to Si, so it glues. Okay, so that's what we wanted to prove, but let's have a look now. So we haven't really used this local representability condition, so this condition here. And now let me give you a reason why we want this condition. So one reason why we want this condition is the following lemma that states that the map I from F to the sheafification, which is given by IU from F of U to the sheafification. So this is of course for all open sets U, and we just map S, the section S, to the germs, and I claim that this induces a bijection on the stalks, and that will become important later. So let's see, how do we prove it? So let's look at the induced map. So we have a diagram, so we have this diagram, so F of U, F X, then we have the sheafification, so this is IU. Here we just take stalks of sections. Here we also take stalks, and here we have the induced map. So we already mentioned this before, and we have this for all open sets U. And now let's see. So the claim is that Ix, for all x, Ix induces is a bijection on the stalks. So let's take so let's consider injectivity. So we have, what does this map do? So we have a section, let's say. So for some u, this doesn't have to be the same u for all sections we consider, but we have here some, so we have some s twiddle in f of u, which then gets mapped via this map to s twiddle x, and this just gets mapped to s twiddle x again. So another way, so that's what we have if we go this way. So that just means that if this is if this is 0, then also this is 0, so it's injective. And for search activity, let's see. So let's take Sx for x and u, so in the sheafification. And now we can locally represent it by some s twiddle in f of, well, let's call it f of u. And now we see that because we can locally represent it, we just take this map here, and then we get s twiddle x is equal to s x. So this just means that s twiddle x is a pre-image of s x. So we have a surjective map here. So ix is surjective. Okay, that's what we wanted to show. So we have this bijection on the stalks, and next time we'll use this to prove the universal property of the sheafification. Okay, thanks for watching, have a good day, and bye.